Good morning again, ladies and gentlemen. Before we start the program, I'd like to request everyone to please stand for the Philippine national anthem to be followed by the morning prayer.
Bayang magiliw, keros ng silanganan, alam ng puso, sa dibdib mo'y buhay. Lupang hinirang, buyan ka ng magiliw, sa manlulupi, kita masisingil, sa lalat at bundok, sa simoy at sa langit mo kamay, ay nilang ang tula at awit sa paglayang tinamahal. Ang isang ng watawat mo'y nagumpay na nakikinig, ang bituin ng araw niya kailan mapalay pagkikinig. Lupa ng araw na maraming pagsita, ay langit sa likod. Aming ligaya dapat may mamagin, at namatay lang tayo sa'yo.
All right, good morning again. Hello sa inyong lahat, Luzon, Visayas, and Mindanao, all over the Philippines. And also, I was informed that we have guests from outside of the country. So hi, everyone, whatever time is it in your country right now. Hello, and welcome to the first ever CropLife webinar. It's a session about MOA, mode of action labeling. So I just had a glimpse of our attendance and we are about 114 participants. So hello sa inyong lahat. I see a lot of familiar names and unfortunately I can't see all of your faces, but welcome, welcome, and welcome. So, and by the way, I am Jerwin Isarza of Aldis Incorporated. I do a little bit of regulatory and a little bit of stewardship on the side, and today I'm gonna be your host. Right now, I'd like to recognize the people in attendance, the audience that we have. For without them, we cannot do this webinar. Kasi kung wala namang makikinig sa amin, then what's the use of this webinar, right? So I'd like to start with the FPA headed by Director Willie Roldan. Thank you for accepting the invitation. Thank you for attending today's webinar, and we hope that especially that the green book, the new green book is up and published. We'll learn about today about mode of action. And also we have people from the BPI or Bureau of Plant Industry. Welcome, guys. We have people from the National Crop Protection Center of the Philippines. Welcome. And I believe we also have representatives from the local government units and representatives from ATI or the Agricultural Training Institutes. Also, I cannot forget our colleagues and friends from the industry, especially yung mga CropLife member companies dyan. So, hi, hello, and nice to see me. Nice to see me because I cannot see you, so I can't say nice to see you. So, also, very importantly, yung mga tao natin from the field because sila yung talagang magkakascade nito to the farmers. So, what we're going to do now is actually for the farmers. Yung CRAN natin, yung CropLife Regional Action Network team, and also the regional offices of the FPA, yung mga coordinators natin from different regions all over the Philippines. So right now, to formally open and to formally welcome us in today's webinar, I am excited and pleased to introduce to you the current president of CropLife Philippines. Also, she is the country manager of FMC Agro Philippines. Ladies and gentlemen, to give her welcome remarks, Miss Veronica Tiburcio. Ma'am, take it away.
Thank you, Jerwin. So good morning and good evening to all of you, and thank you so much for joining this first webinar. And Bo, would you like to please present the first slide? So this morning, actually, our focus is more on insecticide. So this is the first session. And I'd like to say thank you to our stewardship committee and CropLife Philippines, of course, for hosting this one. And we will also have another session for herbicide in August 14 and session 3 for fungicide on September 15. So we hope that we will have more participants in the coming sessions. Next slide, Bo, please. So just to have an understanding of what we really wanted to achieve on this is, aside from a better understanding of the mode of action in relation to resistance management, we would also like to see how actually it is aligned with the new FPA policy on the mode of action labeling. So it's good that we have Director Roldan and the rest of the FPA here. So I think Tita Florence will also give us some background on this one. And of course, any trainings, any meetings without any action plan is really a waste. So what we wanted to do is how we can move forward using whatever we will discuss here. And I hope that it will not only be limited, just like right now, we have from BPI, FPA, DA. So I hope we will also invite more of our industry stakeholders, just like our distributors and even farmers in this kind of trainings. So that would be all for now. So thank you so much for joining. I hope all of you will focus in this webinar and you enjoy as well learning. Thank you, Jerwin.
For the next part of our program, I would like to introduce this very special person. We requested him to give us a short message today. He is currently the Executive Director of the Fertilizer and Pesticide Authority. Everyone, this person needs no introduction actually. Let us welcome the Executive Director, Wilfredo C. Roldan. Sir, are you there?
Can you hear me?
Yes, sure, sir. Clear.
Yes, sir.
Clear.
I hear you. We hear you, sir.
Okay, so thank you
Yes,
very
sir.
much for this webinar initiated by CropLife, specifically from the very active Executive Director Ed Luna. And I would like to congratulate CropLife, the Resistance Action Committee, for initiating this, and for EPA being the regulatory agency of government. We appreciate this initiative, and I would like to congratulate the very intelligent and capable speakers of these sessions, because this is very timely, as we have already released the new Green Book as a guide for all registrations for pesticides. So, but again, the topics here are very important, especially for the stakeholders, to the players, because this is very vital in your role in achieving the role of us as stakeholders and protecting the environment and protecting the farmers. So I think this is a very good beginning for all those players in the industry to level up our knowledge as far as pesticide application is concerned. We have specifically put into the new book the mode of action as a requirement, because we want to see, we want to apply and let the farmers understand the diversification. They have more opportunity to use other pesticides to avoid resistance in the future. So again, I congratulate the leaders of this industry for initiating this very important conference despite the COVID pandemic situation. But again, we in government are with you in this undertaking. And again, I will congratulate the CropLife Philippines and the leaders and the officers of this organization as making this conference very successful. And I will challenge everyone participating in this conference to cascade down to the level of the farmers. The ultimate goal here is to be able to educate down the line to the farmers so that the farmers can decide how to apply the pesticides and avoid the resistance of the pesticide they are using. So again, I congratulate and thank you very much for the speakers. I heard a lot of information and learned here in this very short conference. Congratulations and thank you very much.
All right. You are welcome, Director Willie Roldan. And you heard it from the man. We as an industry are being mandated to, put the mode of action on the label. And as the director mentioned, they have the new Green Book published already. And also, Director Roldan, congratulations as well for publishing the new Green Book. We appreciate it a lot. And as an industry, we will of course, follow what is the new policies and the regulations. Bo, can we have the video of the IRM so that everyone could, listen and see? Okay. So guys, let's watch this. This is very important for a part of our continuous education today. Yeah.
Bakit hindi namatay ang mga peste ngayon? Bakit hindi na tumatalab ang mga pamatay peste na ginagamit namin dati? Pinalitan kaya ang timpla at tapang ng pamatay peste? Kung oo, hindi ka nag-iisa. Ang dahilan ng mga problemang iyan, insecticide resistance o kakayahan ng mga peste na mabuhay at hindi tablan ng mga pestisidyo. Sa panahon ngayon, maraming magsasaka pa rin ang hindi alam kung bakit tila nawawala ng bisa ang mga pestisidyong matagal na nilang ginagamit laban sa mga peste. Ang masama pa nito, kung mapapabayaan ng ganitong sitwasyon, maaaring tuluyan ng hindi tabla ng kahit anong pestisidyo ang mga peste sa taniman. Hayaan ninyong ibahagi namin ang subok na paraan para maiwasan at tuluyang masugpo ang insecticide resistance sa mga sakahan. Ang Insecticide Resistance Management o IRM. Ano nga bang resistance at paano ito nag-uumpisa? Sa isang sakahan na normal ang kondisyon, may iba't ibang uri ng mga peste. Hatiin natin dito sa tatlong grupo para mas madaling maintindihan. Ang susceptible individuals o iyong mga madaling mamatay kapag ginamitan ng pestisidyo. Ang moderately resistant o iyong grupo ng mga insektong madali ring mamatay pero nakakaligtas kapag hindi nasusunod ang mga direksyon na nakasaad sa label ng pestisidyo. At ang mga resistant o hindi tinatablang mga insekto. Malaki ang kinalaman ng susceptibility o ang lagay ng insekto matapos itong maisprayan ng pestisidyo. Sa isang taniman, kapag namatay ang mga peste matapos malagyan ng pestisidyo, ibig sabihin ay susceptible ang mga ito o tinatablan. Pero kapag ang mga ito ay nabuhay, not susceptible o resistant ang tawag sa mga pesteng ito. At dahil namamana ng mga insekto ang pagiging resistant, ito na ang umpisa ng insecticide resistance sa mga sakahan. Paano nga ba namamana ng mga insekto ang resistance? Kunwari, sa isang populasyon ng mga pesteng insekto, kadalasan nagkakaroon ng resistance ang mga peste kapag mayroon itong minanang resistant forms at biotypes mula sa kanilang mga magulang. Ito ang mga espesyal na katangiang na isasalin sa pagitan ng mga insekto at ang dahilan kung bakit nagiging resistant ang mga ito sa epekto ng mga pestisidyo. Kapag hindi naagapan, maaaring manahin ang espesyal na katangiang ito ng ibang populasyon ng mga peste hanggang sa tuluyan ng mawala ng bisa ang mga pestisidyong dati ay epektibo. Ano-ano kaya ang mga bagay na maaaring maging sanhi ng pagkakaroon ng insecticide resistance? Una ay ang target organism o insektong gustong puksain. Sa isang populasyon ng mga insekto, minsan ay mga high-risk na peste na sadyang mabilis mag-adapt at mag-adjust sa mga mode of action o paraan ng pagpatay ng mga pestisidyo. Dahil dito, kung paulit-ulit na pestisidyo na may parehong mode of action ang gagamitin sa sakahan, hindi malayong mag-develop ng resistance ang mga high-risk na peste. Ilang halimbawa ng mga high-risk na peste ay ang mga diamond-backed moth, mango leaf hoppers, at thrips. Pangalawa ay ang produkto. Bawat kemikal ay mayroong sariling insecticidal activities na nagtatakda kung ano-anong mga peste ang tinatablan at hindi tinatablan ng mga ito. Nakadepende naman sa residual control kung hanggang kailan ito magiging epektibo laban sa mga target itong peste. Kung hindi mababantayan, maaaring maging dahilan ng resistance ang mga ito. Pangatlo ay ang intensity of use o tindi at dalas ng paggamit. Nakapaloob dito ang mga sumusunod. Labis na pagdepende sa isang single mode of action, bilang ng pag-spray kada crop cycle at kada taon, dami ng pestisidyo at pagitan kada spray, iba't ibang klase ng pestisidyo mula sa iba't ibang mga kumpanya na pareho ang mode of action, mga magsasakang kulang ang kaalaman sa insecticide resistance. Sa listahan ng mga ito, tanging ang pangatlo lamang o yung intensity of use ang kayang kontrolin ng mga magsasaka. Ibig sabihin, ito ang mga bagay na dapat isaalang-alang ng mga magsasaka para epektibong maiwasan at mahinto ang insecticide resistance. Para maisalarawan ang nangyayari sa mga sakahang nagkakaroon ng insecticide resistance, masdan at pag-aralan ang mga halimbawang ito. Tanging ang mga tinatablan at hindi tinatablang insekto lamang ang sadya namin ipapakita para mas madali ninyo itong maunawaan. Pero dagdag din lang, ang mga moderately resistant na mga insekto ay patuloy pa ring nabubuhay kasama ng mga tinatablan at hindi tinatablang insekto. Sa unang pag-spray, agad na mamamatay ang mga tinatablang insekto habang mabubuhay naman ang mga hindi tinatablan. Dahil sa mga iba't ibang dahilan na nakakaapekto sa pagiging epektibo ng pestisidyo, sabihin na natin 25% ng populasyon ng mga peste ang mabubuhay. Inaasahan na natin na lahat ng mga hindi tinatablan ay mabubuhay habang ilang insekto tinatablan lamang ang matitira. Dahil sa pangangailangan ng mga insekto na magparami, maghahanap ang mga ito ng kapartner. Ang mga insekto makakahanap ng mga kapartner ay magkakaroon ng mga anak base sa kanilang mga katangian. Ang resistant na nakahanap ng kapartner na resistant ay magkakaroon ng mga resistant na anak. Samantalang ang mga resistant na nakahanap ng kapartner na susceptible ay magkakaanak naman ng magkahalong resistant, susceptible at moderately resistant. Habang ang mga susceptible naman ay nakahanap ng kapwa niya susceptible ay magkakaroon ng mga anak na puro susceptible rin. Sa patuloy na paggamit ng mga pestisidyong pareho ang uri o magkatulad ang mode of action, inaasahan na lalo pang dadami ang bilang ng mga resistant na insekto. Patuloy ring mabubuhay ang mga ito kahit nadagdagan pa ang dami ng pestisidyo. Hanggang sa punto na mapapansin na lamang na magsasaka ng populasyon ng parehong insekto ay hindi na namamatay. Dito na magrereklamo ang mga magsasaka na ang pestisidyo na dati nilang pinagkatiwalaan sa pagpatay ng mga peste ay mahinang klase na at hindi na epektibo.
I hope you guys understood the video very well. Presentation, konting backgrounder lang yun. We cut it short. Actually, we have a full video of IRM para mas lalong maintindihan nyo talaga. But here's the thing. If you want the complete IRM video, you can just visit the CropLife website. So, and also you can download it for free. You may want to write this down. The CropLife website is croplife.org.ph. So again, that is croplife.org.ph. You can download a lot of videos there that could, help you from whatever problems you have in your field. So, okay, so let's move on. We have to start the first topic this morning, and to introduce our next speaker, I'd like to call on Ms. Kathy Sumagaysay, the Stewardship Manager of Syngenta Philippines. Ms. Kathy.
Thank you, Jerwin. Good morning to all. Taking my part, I would love to introduce to you our first speaker. She graduated from the University of the Philippines as an entomologist and started her career with the industry, the Bayer, in 1981. After she took several regulatory positions at Bayer, she became the company's technical manager in 2004 and retired in 2014. Fresh from the retirement, she joined Syngenta in 2015 as product biologist assistant, and in the late 2017 became the head of the crop protection development. Today, she will discuss the topic on mode of action labeling. Just an information that during her discussion, if anyone has clarification or questions, please feel free to express it via the Q&A button, which can be seen on the lower part of your screen, or it could be an active engagement by raising your hand during the Q&A portion later. So to start with, let us all welcome our first speaker, Ms. Florence Vasquez.
Hello, everyone. Thank you, Kathy, for your introduction. Thank you very much. So, good morning, everyone. So, hello and welcome to this webinar on MOA labeling. Okay, actually, this is a milestone for us. You know why? Because we will be training you on this MOA labeling, which is a critical tool, no, to manage insecticide resistance. Okay, so just to give you a background, as far as we are concerned in CropLife, we started our advocacy on resistance management way back 2008. No, we established this diamide working group, no, which is composed of Syngenta, Bayer, and DuPont, and we try to manage resistance of diamides. And then in 2013, CropLife International, recognizing our efforts on this working group, no, they elevated us, or we transitioned to IRAC Philippines. We are the first ASEAN or ASEAN member of the IRAC International Group. So it's actually a big honor for us. And during that time, okay, we already started working with the regulatory agency. Okay, we work with the regulatory agency as far as, on this MOA labeling, because we wanted to include the MOA on the labels. But it took us quite some time. It's only up during the time of Director Roldan, our present FPA director, no, last year, when he recognized the importance of MOA labeling as an important tool to manage resistance. So he improved, and now MOA labeling is actually part of the registration guidelines, the new policy. So it's actually being in this journey, okay, for quite a long time. I'm really very honored to be your speaker on this particular topic. So welcome, everyone. A while ago, you saw, okay, a video on how resistance develops. Okay, you have three factors: the pest, the product, and intensive resistance. Why? Because sequential application of or resistance. Why? Because resistance, develops through selection of our individuals when you use the same mode of action. Okay, so how can we address this? How can we address this? So we need to alternate the use of different MOA. And the rationale of alternating different MOA is when you alternate different mode of action, okay, the frequency of genes, now because we're talking about heredity, we're talking about genetics here, the frequency of genes or individuals with to resistance will decline. And therefore, this will increase product longevity, which is of course good for the farmers as well as to the industry. Before I dwell on my MOA presentation, I would like to, share with you how insecticides work, because this is very relevant to MOA labeling, no? So insecticides work by affecting an essential activity in certain biochemical process in the pest or in the insect. Like for example, respiration, which is responsible for energy, nerve and muscle function for movement, growth and development, and mid-gut processes. As an example, let's say organophosphate, which affects nerves, no? It affects nerves by inhibiting acetylcholinesterase. So acetylcholinesterase is actually the target site of organophosphate. So even it affects the nervous system, but the main target site is actually the acetylcholinesterase inhibition, okay? Now let's go to another example, synthetic pyrethroids, no? It also affects the nerves. But how does it affect the nerves? By modulating on the sodium channels. And these sodium channels actually regulate the flow of sodium, okay? And if there is more sodium, then you will have paralysis later on. So the main target site for synthetic pyrethroids is the sodium channels, okay? So the target site, as mentioned in my previous slide, no, is the specific biochemical process affected by an insecticide, okay? And active ingredients which affect the same target site have the same mode of action, okay? So you can see in my previous slides that organophosphate, for example, has a lot of AI, no? And this AI has a lot of formulations, and this formulation has a lot of brand names. So you would imagine, for example, that there can possibly more than 200 brand names, no, in just one mode of action. For example, this case of cypermethrin. Cypermethrin is about more than 100 brands, no, under synthetic pyrethroid, no. So for synthetic pyrethroids, maybe we have about 300 brands for this mode of action, okay. So this is actually the list of MOA. I just want to share with you. This is actually the MOA, or the different mode of action that are being classified by IRAC. Classified by IRAC under nerve and muscle targets, we have several mode of action, and this will be discussed lengthily later on by our next researcher, no, and the next speaker. Sorry. So this is very important to know because, for example, the MOA, acetylcholinesterase inhibitors, these are the organophosphates. This is MOA number 1. These MOA are designated by IRAC. They were the one who developed this in the past. No, they started probably with the old compounds, and now with the new compounds like 30 GABA-gated CL channel allosteric modulators. These are new mode of action, just recently added by IRAC. Okay, and also MOA 32. MOA 32. Okay, so you can see that because there are a lot of MOA or a lot of brands, okay, a lot of brands in a certain MOA, possible brands in a certain mode of action, we need to do something. We need to train the people. We need to train them on how to alternate, different MOA, because if they will alternate it by brand, it's not, alternating it by MOA. So this is the reason why CropLife now is doing this training for you, no? CropLife and its Resistance Action Committee address this by understanding mode of action, and this is the reason why we are having this talk. The speaker will be discussing, the next speaker will be discussing with you the specific MOA, and I will be discussing with you the MOA labeling, because this is very important. No? RACs provide communication resources on MOA, and we would like to include MOA information on product labels. because this is the initial document that can be seen by farmers when they buy the product. A label is a legal document, so anything that you put on there is legal. Okay, so it's very important that we legalize this information. So now, what is our industry commitment? We want to include more information on product labels, no? Because this is very critical for the growers to manage resistance. And this is the reason why for quite some time we tried our best to discuss this with the FPA, that they approve our proposal on MOA labeling, and we are really very grateful to the authority under the leadership of Director Roldan, who actually recognized the importance of resistance management in sustainable agriculture. So MOA labeling is now required in the Philippines and also required as mandatory requirement in other countries in APAC, no? Including the Philippines. And just to share with you the status of MOA labeling in other countries, you can see here that there are some countries where MOA labeling is still voluntary, meaning to say you can put it as you wish. But in some countries, it's mandatory, meaning to say the regulatory agency mandates its inclusion on the product label. So that includes the Philippines. And also, CropLife encourages all pesticide manufacturers worldwide, okay, to include MOA information on their labels, because we think that this is a critical tool to manage insecticide resistance. So CropLife members have made a voluntary commitment to include MOA information on all product labels by 2023. But of course, in the Philippines, since FPA already mandate it in our green book, in our new green book, then we can already start, putting all this information on the labels. Of course, some companies have already initiated this long time ago as voluntary, because we wanted already to advise the farmers as early as possible, no? So how do we put this information on the label? Do we need to put the very technical of highfalutin words like cholinesterase inhibitors, sodium channel modulators, ryanodine receptors modulators? Do we need to put this on the labels? We need to put something on the label which is very simple, which can easily be understood by the farmers. And we CropLife thought of using icons, no? To provide clear and simple method to help users determine the type of pesticides and its MOA group, no? So that we can practice rotation. And when I show you before, no, the previous slide I showed you before, you can see there that there are respective numbers for each mode of action. So this is how CropLife, this is the CropLife proposal in terms of, putting the MOA information on the label. So we would like to put icons instead of this very technical, highfalutin words, okay? So we would like to put the group, okay? If your mode of action is 28, this refers to ryanodine receptors, then we put the group of insecticide there, which is 28. And then we indicate also the type of insecticide, the type of product, which is insecticide. And this will actually help the growers and extension workers, no? In order that they can actually easily understand how different MOA can be alternated. Because if you put these technical highfalutin words, it will be very difficult for us to train the farmers. So if you just see there one, then you don't need to use one in your next application. You may probably use number 2 or number 3, depending if these products can actually control that particular pest that you would like to control. And aside from this, these icons, we also would like to support the label with some resistance management statement, no? Because every product has a different way, no? different way of managing it. No, so they might require different number of applications, no, throughout the season. So we also encourage the companies to put, aside from these icons, to put something like a resistance management statement on the particular label. So what is the current situation in the Philippines? Okay, the current situation in the Philippines is that rotations of pesticides no, belonging to different mode of action is not generally practiced yet by the farmers due to lack or poor understanding of MOA classification. Because MOA is a very technical thing, no? It's not something that it's very difficult to actually explain to the farmers. So farmers actually are more inclined to using pesticides, you know, according to brands, because this is how we actually tried, no, before as an industry, you know, to promote to them. Okay, so and one active ingredient has probably more than one brand, 100 brands, as I mentioned. Many active ingredients can belong to one MOA classification. Okay, and since 2012, CLP members have been training farmers on resistance management. As I mentioned before, we did not do this only 2019 or 18. We've started this long time ago, but because it's really very challenging, no, to teach them on rotation, no, putting these icons, okay, will definitely help them a lot. No, it is very simple. Okay, so we actually submitted to FPA, okay, a proposal to include MOA on the labels. And actually, as I've said, no, this was approved by FPA, by Director Roldan, and we are very grateful for this. So as far as as far as MOA labeling is concerned, okay, this is actually what is included in the new FPA guidelines, no, how it should look like, no. So in our recommendation, previous recommendation to them, of course, we only recommended group plus mode of action and then the type of pesticide, but FPA would like to include also the active ingredient on these icons, no, to be included on these bars. But you know, my discussion yesterday with one of the FPA colleagues, I tried to convince them that, you know, it will be very challenging to put already the active ingredient, no, because if we put this on the front panel, you already have a requirement from FPA to indicate the active ingredient there on the front panel. So if we place this bars on the front panel, it will be very repetitious, and at the same time the space may be challenging. So we can still discuss this with FPA on how to move forward on these icons, no, what is the final thing that we have to do. And then we need to actually put, as I've said, a resistance management statement which includes a specific resistant management strategies for your product, no, because this is different from one product to another. So in summary, resistance develops, okay, I will say it again, resistance develops through selection of our individuals by using the same mode of action continuously, and that frequency of genes for resistance to an insecticide will decline during application of an alternative insecticide with different MOA, increasing product longevity. Growers and extension workers and other stakeholders, no, need to recognize and understand which product can they rotate, and this is through MOA labeling. And MOA labeling is a critical component to educate the farmers in managing resistance. So before I end my presentation, I would like to extend my deepest gratitude to CropLife, the board of directors, and especially to the Resistance Action Committee team members for their unending and unwavering support to all our resistance management activities. So Thank you so much, and that ends my presentation. Back to Kathy.
Thank you, Miss Florence, for elaborating the importance of the mode of action labeling through rotation by mode of action and for stating the CropLife members' commitment. So for now, we are open for the Q&A portion. We have one question here from the participants. From Nicole Perez. Miss Flo, the question is, I just want to know the difference between the original and generic insecticide.
When you talk about that was registered, I think it depends, no, because nowadays, for example, no, a lot of products are already generics, no, a lot of products are already generic. When you see a product which has no equivalent or the same AI, no, as the one which you see in the market, okay, then it means that it's still proprietary, no. For example, let's say I will be talking about a proprietary product. This is Syngenta. I'm sorry, I know Syngenta. For example, isoparazam. This is a proprietary product, no? We just registered this probably 2 years, 3 years ago. So FDA gives 8 years of data protection. So once 8 years lapse, then there will be a lot of isoparazam, no, in the market already. So this is how you differentiate. If there is nobody which is no active ingredient similar to this to the active ingredient that is available in the market, then that means that that active ingredient is still proprietary. If there are other active ingredients available, then this will be a generic pesticide already. Did I answer it right? But when it comes to MOA, okay, generic, whether it's generic or proprietary, if they have the same mode of action, okay, then they will belong to one MOA. Yeah.
Thank you, Miss Florence. I hope, Nicole, you have answered your question. We have someone raising his hand. Doc Hill. Doc Hill Magsino.
Yeah, good morning. Morning, Kathy.
Yes, good morning, Doc.
Okay. Hindi ko ma-type kasi medyo mahaba. So, first of all, I would like to congratulate Ms. Florence for a very informative presentation. Congrats, Madam Florence. As we discussed before, this is not a question, but a reminder that for more effective MOA labeling or knowledge info campaign or transfer, dealers or retailers are considered frontliners in this endeavor. So they're the first person being approached by the farmers. Hence, they must have a deep understanding about MOA labeling. And we suggest dealers, together with regional and provincial FPA officers, which are frontliners as well, must have also a special training about understanding the MOA labeling implementation among farmers, aside from the CropLife own farmers training. And second, reminder, it's good that our label will have soon a MOA icon. Now, we must be clear as well that different MOA icon, sasabihin ng isang dealer sa farmer, okay, ito na po yung MOA group na ginamit nyo para huwag magkaroon ng resistance, ito pong another group ang gagamitin. Now, my reminder is be careful recommending another MOA group. They should be sure that the target pests are registered in that MOA.
Yeah.
Hindi lahat ng MOA group could kill or control the specific pest. Yun yung part of the training that should be emphasized. Marami pong salamat.
Yeah. Thank you, Doc Hill. That's why I emphasized a while ago in my presentation that, you know, the MOA number that they have to choose is the MOA which is also effective on that particular pest. And I believe that you know, we also need to train the distributors because you know, they are the one actually being approached sometimes by the farmer. In fact, we tried, to invite them also in this particular training. If I recall, we sent them invitations also, the KIL, to participate in this particular training because we believe the importance of dealers and distributors in terms of MOA knowledge. Okay, so thank you so much, Doc Kiel, for the builds, and rest assured that if what we will do is we will check which of those distributors registered and attended this workshop. And if there are still some distributors, then we can schedule, a different forum. Probably the front people can handle this already, Kathy, and then they can actually, train these distributors who did not attend this training on this particular, topic, which is mode of action labeling. Because you're right, this is very important. You cannot just, say, okay, use this different number. In fact, this number is not actually effective for that particular pest. So this is one thing which is, this is well noted, Dr. Hill. Thank you so much. Kathy?
Yes, thank you. Just to add, the CropLife network by region will also do a campaign so as to disseminate the information on the mode of action labeling. Now we'll be having the last question from the participant, Mr. Doki. Ms. Flo, he is asking, with the approval of the government for a huge amount to purchase insecticide against FAO, how can CropLife help or assist the government in selecting different types of insecticides?
Okay, that's actually, we actually already prepared, the list of products, registered in FAO. Actually, it's actually a program of CropLife. We did this, I think. I saw this document, So in this document, you will
Frozen.
business point of view, actually, I insisted this MOA to be placed on each particular active ingredient or brand registered for FAO, because this is very important. We might have so many registrations, okay, for FAO, but so many actives, this on the same MOA. So we need to, inform the farmers and other stakeholders. So we have this document already, and I think it was prepared by CropLife. We have the product listings to include the MOA numbers. So I think this is something we can do to promote resistance.
Okay, we get the message from Ulysses. Thank you to Ms. Florence. Now, for those unanswered questions, CropLife will just send the answer through email or any means to contact you the soonest possible time.
Thank you, Ms. Florence and Ms. Cathy for that very, very informative question and answer portion. And as Ms. Cathy said, there are a lot of questions that has yet to be answered. We have our Q&A tab, and we saw 6 questions actually. A lot of them are very, very, relevant to the topic mentioned by Ms. Florence. So we will answer it in the background. So wait for the answer. Ms. Florence can actually read it and answer it right now. So, and thank you, Ms. Florence, for that very wonderful mode of action information. And to introduce our second speaker, yes, we still have a second speaker about mode of action. And I'd like to call on Mr. Oscar Idralin from the FMC Agro Philippines, the R&D manager. Sir?
Thank you very much, Jerwin and Kathy. Our honored guests and participants to this morning's webinar, good morning and good evening. It's an honor for me to introduce our speaker who will be talking on the topic mode of action of insecticides. Our speaker this morning is a senior research fellow at the FMC Corporation and is located at Stein Research Center in Newark, Delaware in the USA. He has dedicated 38 years to the ag chem industry as an employee of DuPont Company from 1982 to 2017, and thereafter with the FMC Corporation. He's also the Global Technical Product Manager for Rynaxypyr and Indoxacarb insect control products, whose responsibilities are to manage global development programs, maintain their technical foundation, and transfer technical knowledge. Our speaker leads the FMC corporate effort to maintain pest susceptibility to FMC's insecticide portfolio, particularly the diamide products. He's an active leader in the International Insecticide Resistance Action Committee, or IRAC, and participates in numerous industry activities that promote the development and implementation of insecticide resistance management, or IRM programs, aligning company product labels with stewardship values, and he champions the incorporation of IRM into corporate business plans and culture. He coordinated the Vegetable Integrated Pest Management, or IPM, programs in New York State while a member of the entomology staff at Cornell University at the New York State Agriculture Experimental Station in Geneva, New York from 1978 to 1982. And last but not the least, I would like to mention that he has been one of the key supporters of CropLife's IRM efforts in the Philippines. So I am honored to introduce to you my esteemed mentor, Dr. John Andaloro. Oh, as a reminder to our participants again this morning, if you have any questions on the matter, kindly write them down in the Q&A tab, and we'll read them during the Q&A portion after this. Dr. Andaloro, the floor is yours.
Okay, thank you, Audie. That was a very nice introduction, and I greatly appreciate that. This is quite an honor. I didn't realize this was such a milestone in Philippine history, so to be able to participate is quite a privilege. So I'd like to thank the CropLife Philippines Board of Directors. I'd like to thank Ed and particularly Veronica, Kathy, who's helped us, Jerwin as well, Florence, Audie, you guys have been assisting me for over the past 2 weeks. What I'm going to do now is let me share my screen. Okay, what I'm going to do is talk to you about mode of action, and I'm going to pick up where Florence essentially has left off. And so I've got my presentation really split into 2 parts. One really is to continue talking about the labeling piece, but then also to get into a bit more technical aspect of mode of action. Okay, good. Okay, that was exciting. What I want to point out here, and it was mentioned, I think, in the movie as well as Florence, and that is when we talk about insecticide resistance, it's based on genetic selection. Key here is genetics. That means resistance is transferred by genetic traits. That means that there's a mom and there's a dad, and they mate and they transfer their genes to the offspring. And as we look on the right-hand side here, as we talk within the industry, we talk about red, yellow, and green flags. And I have been working with the Philippines team now for the past 12 years. And when we started, believe it or not, the diamides actually were susceptible to diamondback moth. And over time, we started seeing a yellow flag, which essentially is suspicious populations, and those that we need to do more research on and monitor. And then eventually, based on additional selection pressure and overuse, we wind up with red flags. The point is that when we get into a red flag situation, that means there's a field failure. That means that we have verified it in laboratory. It is very difficult to turn this around. On the other hand, a green flag represents those markets which we have susceptible insects. That is worth their weight in gold if you have a market where your insect pests, whether they're weeds, diseases, or insects, are still susceptible. And here is where you need to pay attention. We typically spend a lot of time in the red area when we should be spending more time in the green area because we want to prevent resistance. Okay, this was shown in the movie, but this is a good genetics class. Essentially, we just need to remember that the population is made up of resistant, moderately resistant, and susceptible. But what's really key here is that you need to understand is that most of the population is made up of heterozygotes. It's made up of the RS, or the moderately resistant or moderately susceptible. as much as 75%, 80% of the population is made up of this category. And you look to the right, it's got one resistant allele. But this is the area here. These are the individuals that we really try and remove from the population. And that's what's really critical. Okay, so what is insecticide mode of action? Essentially, mode of action defines the process. It defines the site where the insecticide works in the insect, on the outside of the insect, typically at the molecular level. And as Florence pointed out, we talk about mode of actions, at least with insecticides, as group numbers, all the way up to 32. This is a publication by IRAC, which is nice and small, fits in your back pocket, but it's a great reference. Okay, why do we know the mode of action of insecticides? Again, as pointed out by Florence, that is the key to managing resistance. And I'm going to point out, we're talking about target site resistance here, okay? And I'll talk a little bit more about that in a minute. There are about 32, as was pointed out. I think I've got 31 shown here. 32 is now viruses. And so these are all novel modes of action. What does that mean? That means that if you have resistance to group 1, which is carbamates and OPs, that there is not cross-resistance to diamides, which are group 28. And if you have resistance to pyrethroids, which are group number 3, there should not be cross-resistance to spinosad, which is group number 5. Okay, very important. But to give you an idea, when we talk about target sites, what are we talking about? We're talking about these sites within the insect that could be chloride channels, sodium channels. They could be rhinodine receptors or calcium channels. It could be chitin, which is the exoskeleton on an insect. All these particular sites on an insect that are critical for survival can be disrupted with an insecticide. Okay, now we're talking about target site resistance, and that's really what we are basing our discussion on, and all of our focus is on target site. But remember, there is also metabolic resistance, okay? And here's the difference. Target site resistance means that you spray a molecule, and that molecule then is taken up by the insect, and it finds the target site. And here's a target protein. That target protein, essentially, it allows some life-sustaining process to occur. And what happens is the molecule binds to this particular protein, and it shuts down the process. Now, with target site resistance, because of mutations, because of selection pressure, because of genetics and the increase of resistant populations, this particular target site has been altered, again, because of a mutation. What happens now is that the molecule, as it tries to interact with this target site on a resistant insect, it cannot bind with it. And what happens then, it's not able to shut down the system, so the insect lives and is able to continue surviving. Metabolic resistance is a bit different. Metabolic resistance, you're still working with a target site that's not altered, it's not mutated, but there are enzymes within the insect. And these enzymes on resistant insects can have high levels of all different types of enzymes. And what these enzymes do is they mess up the molecule. They can break it down into smaller pieces. They can add particular atoms and make it larger. The point is that these enzymes alter the insecticide molecule, and it no longer binds with the target protein. And what happens when it doesn't bind? It means the insect is resistant and it survives. Okay, so again, we have target site resistance, we have metabolic resistance. Our focus right now with the mode of action numbers are relative to target site resistance. Now, just to pursue this a bit longer, metabolic resistance, typically, if there's resistance to one active ingredient, it usually doesn't confer resistance to other actives, okay? And there are biochemical targets that differ in their propensity to develop resistance. And by example, what I'm going to say is the nicotinoids as a great example. They've been in the market for decades, but yet, most of the resistance that we have found through the first 15 years plus has been metabolic. And now only recently are we starting to find target site resistance. The diamides, on the other hand, from the time that they were introduced 18 months later when resistance occurs all the way up to the present, the majority of resistance status that we find is target site. So we see differences, I'll say, in the susceptibility of different target sites and their propensity to develop resistance. Now, what's really important to realize is that unlike metabolic resistance, if you have target site resistance to one of these actives, acetamiprid, essentially that means that none of the other neonicotinoids will then work. If you have resistance to chlorantioniliprol, that means that the other diamides will not work. We have seen in Asia, when we first got resistance of flubendiamide to diamondbacks, then chlorantioniliprol, we found that cyantraniliprol was still working, but only for about 6 months, and then eventually it did not work. So that is why when we talk about target site resistance and why we spend so much time on it is because it can kill an entire category. It can wipe out all the products in a particular group mode of action number. Okay, very, very important and very dangerous. Okay, so how do we resolve this? What's our solution? As was pointed out earlier, we rotate insecticides. We follow the rule to prevent resistance. We alternate insecticides with different modes of action. Ideally, you'll hear people talk and you'll see it in our labels. We try not to treat 2 successive insect generations. It's really hard sometimes to figure out what a generation is, when it begins, when it ends. And so then we talk about windows, which are 30, 35-day windows. And we talk about using the same mode of action products within a window. And then we talk about rotating these windows, okay? Because the bottom line is that we don't want repeated exposure of the pest populations to insecticides with the same mode of action over a long period of time, which is why for us rotation is so critical. Now, really need to pay attention to this one because this is a question that people in the field, you are the frontliners, you are the trainers. This is a question that typically you will often get. Well, wait a minute now, am I supposed to rotate for resistance management or am I supposed to mix? Am I supposed to buy pre-mixes or am I supposed to do tank mixes? There are differences between resistance management for fungicides and herbicides versus insecticides, and this confuses the hell out of the customer, okay? For insecticides, our most preferred is rotation. However, you talk to a plant pathologist and you talk about their resistance management program, it sounds like in August, you will be hearing experts in September from both of these. They will be explaining why they prefer mixtures. Herbicide specialists, they prefer mixtures, but insecticides, we prefer rotation. The bottom line, as you really push the fungicide and herbicide colleagues, they'll say, well, what's acceptable is rotation as well, but this top line is really what's preferred. And the bottom line is that whether you rotate or mix, you still have to know modes of action, okay? For fungicides, herbicides, insecticides, it's still critical. But remember, for insecticides, you rotate. Very simple. For the grower, for the customer, what does he need to understand? 3 things. What's the mode of action for each product? Where can you find it? What do I do with it? That's one of the biggest issues. We have a lot of companies who are putting the mode of action on the front page of labels, but they're not explaining what you do with it, okay? So what is the mode of action for each product? You'll find it on labels. You'll find it on customer communications. You'll find it in that pamphlet that I showed you. You'll find it in all different types of areas. And ideally, where to find it is just put an app on your cell phone. And you can download it for free. This is the IRAC International Mode of Action. And all you need to do is just type in IRAC MOA, and it's pretty visible and discernible for anything else that's out there. And you'll be able to search for active ingredients right from your cell phones. Now, that's where to find it. That's what it is. Now, what do you do with it? And this was referenced by Florence just earlier. So for the ag chem companies, for the CropLife companies that are out there today listening, this is an absolute requirement. For FPA, this is an absolute requirement. Just putting the mode of action icon on the front page or somewhere in the label is not enough. You need to explain what do you do with it. And not just for insecticides, it has to be done for fungicides and herbicides as well. So very simply, CropLife International and CropLife International is now beginning to recommend, and I'll say mandate, but that's within reason. We're saying 3 things need to be on the label. 1, the mode of action group number. We're also saying that you need to have a statement, and this is in the recommended label statement, the mode of action group number, some type of a comment about avoid treating consecutive generations, and the third point is rotating. And I've got a simple label here where I pointed out number 1, 2, and 3, the mode of action number, the 2, the comment about avoid treating consecutive generations, the third point, rotate, use application windows. 3 very simple items, and this is what needs to be communicated to growers. And if you want a visual, here's a great one produced by the Philippine diamide team 8 years ago, 9 years ago, that both Audie was on. Florence led this group and created some great communications for the growers, very simple ones, but here's a mode of action rotation by windows. This happened to be for diamondback moth. Here's the generations throughout a particular crucifer season. And you can see where we're rotating mode of action X's, Y's, and Z's. And there's 2 options here. Actually, within the middle of the season, you can rotate mode of action Y with mode of action A. The point is that wherever you use a mode of action in one window, you do not use it in the next window. Very simple. And here's a great recommendation. And what's not recommended is using the same mode of action through the entire season. Okay. What's also very important, we're talking a lot about mode of actions, but also realize that when we talk about a mode of action, very often the products in that same mode of action have fairly similar characteristics. And so that's kind of important to know the attributes. And so as a frontliner, you need to make sure that you are communicating the attributes of products to the customers and to the grower. And what does that mean? That means the grower needs to know, is this a contact product or is it an ingestion product? Does it take out adults? Is it ovicidal? What type of broad spectrum, any type of spectrum does it have? Does it take out leps as well as sucking insect pests? What's its impact on beneficial safety? Is it a systemic translaminar product? Also, really very critical is knowing the spray timing and number of applications. Treatment thresholds differ by product, okay? Do not believe that one treatment threshold fits all products. If you're working with a pyrethroid, your threshold may be at first larvae or first site of damage, because you can use it as a rescue treatment. If you're talking about the diamides, you do not want to do that. You're looking now almost way back. You're looking at adult flight. You're talking about the beginning of egg lay because it's an ingestion product. Very, very critical. So you can lump pyrethroids, you can lump diamides because they're the same mode of action. So you can begin to understand, you need to teach your customers that they can use the mode of action number as a possible indicator for attributes and also the impact it's going to have with regard to thresholds. And why is this important? All these things impact resistance management. Every time you make a spray, you need to maximize your control, your kill in the entire generation. What does that mean? That means you need to take out as many multiple pest stages as you can, not just the larvae, but you need to try and take out the adults. You need to try and take out the eggs. And that is, you need to have maximum kill. And that's what removes the heterozygotes, the RSs, from the population. Does it conserve beneficials? Early in the season, you really want to use products that are conserving beneficials because they assist in resistance management. It's part of IPM. What happens if you use the wrong threshold? You wind up using a pyrethroid threshold for a diamide, and you wind up having larvae that are still living. That's poor timing. That means poor control. That leaves heterozygotes in the population. So all of these are all critical. They're all related to mode of action, but they're specific to the attributes and they're specific to the products. Okay. Now I'm going to spend the second half of this presentation getting a lot more technical and trying to understand how insects bind to target sites, how they attack target sites at the molecular level, is complicated, and this is not something that you really want to communicate to customers, okay? It's confusing. However, as an influencer, as a frontliner, as a trainer, and as an expert, there's probably some level of understanding that I think would be helpful to you. So I've got the next couple of slides. I want to go through a list of insecticides that Florence gave me, and I want to try and explain to you how they impact the insect at the molecular level. So that gives you some insights. Florence showed something very similar. These are all the different target sites that affect lepidopterans. These are all the target sites that affect sucking insects. And frankly, many of these modes of actions affect both lepidopterans and sucking insects. So they're broader spectrum. But what we do, I think was alluded to by Florence earlier, is that we tend to break the activity up into these categories: nerve and muscle, growth, respiration, midgut, and then there's some we really don't know. They're unknown. But what is important to know is that if we look at all those modes of action, those products, those chemistries that are in the nerve and muscle and in the growth category, that represents 95% of the current commercial available products. Okay, so these top two are really important. And frankly, I'll bet probably 80% or 75% are in the nerve and muscle area. Okay, let's look at a crude diagram of a neuromuscular pathway. This is a signaling pathway. This is as the nerve and messages from external stimuli, from an ingestion of a molecule. This is where the stimuli moves from the left to the right. Okay, it moves from the central peripheral nerve. It goes down the sodium channel. There's a release of something called a neurotransmitter, which essentially it's a chemical messenger, which is acetylcholine. We see it go across this gap right here, and we call that essentially it's a really, well, what's the word I want to use? But we'll say it's just a gap at this point in time. It looks a lot wider here than what it actually is. Then you have the receptors on the other side that receive the acetylcholine, and they're called and break it down, and they're called acetylcholine esterase. And now this is the motor nerve. And as you continue down the motor nerve toward the muscle fiber, there's another group of receptors which are called GABA receptors. And then once we get actually into the muscle, we start talking about mitochondria, which produce energy. We start talking about ryanodine receptors, which regulate calcium. So this is a great picture that just shows you all the potential sites that can be and have been exploited and utilized by many agricultural chemical companies to control insects. Okay, so let's start with the first one. So far left, these are disruptors of the sodium channel. So we got the pyrethroids and we have the oxidizines. And so the pyrethroids you're very familiar with: bifenthrin, cypermethrin, lambda, permethrin, oxidizines, indoxycarbon metafluomazone. Okay, now what's interesting, what's really cool about this, is they both affect the sodium channels. However, one opens the sodium channels and allows sodium ions to just flow in unregulated. Then you have the oxidizines, which block it and don't allow any sodium ions to flow in. What's interesting is both processes paralyze the insect. However, they do it the exact opposite way. Now, what happens if you combine these two in the tank? Nothing. They both work. They work as a tank mix. They work solo. It is interesting. You would expect to see some type of antagonism, but you don't. But it is interesting how both of these do the exact opposite thing to sodium channels. Okay, now let's look at the organophosphates and the carbamates. Now you see we're moving a little bit further now from left to right, and we're now looking at where there's nerve conduction. There's a movement of the sodium channel transmitter, again, acetylcholine, and it's moving now toward the muscles, and it's trying to send messages over to the muscle. And there's this gap here, which really we call a synapse. It's a neuromuscular junction. And this is where the message is delivered. It has to cross this juncture. And so acetylcholine crosses it over to the motor nerve. Well, now it's going to be broken down, because if it isn't broken down, it's going to continue sending the message, sending the message, sending the message. So what does the carbamates and OPs do? They destroy acetylcholinesterase. They do not allow the breakdown of acetylcholine. So what happens is it overstimulates. It hyperexcites the insect to the point where it dies. It's like you drinking 10 cups of coffee. How do you feel after you do that? Except you'll survive that. Insects are not going to, because it hyperexcites them. Okay, now let's look at the group of insecticides that impact the motor nerve. And this is, we're still in the area that OPs and carbamates work, but we're looking specifically at acetylcholine neurotransmitter. And these are affected by the neonics, by spinosades, and by CARTAP. And they have a wide range of impact. They range from super stimulators to process blockers. And so you've got the neonics, as you know, acetamiprid, dinotetraon, imidacloprid, thymofoxam, thiacloprid. Then you have this group that isn't necessarily all that popular. It's the neuricetoxin analogs used in rice and a number of other crops. Well, they also block and paralyze, and they attack that same area, not necessarily the exact same site. Remember, keep in mind, every time you have a different mode of action, it's a different site on, in this case, the nervous system, but it's sometimes they can be very close. But then now these two paralyze. What does spinosad does? Spinosad hyperexcites. So you have hyperstimulation. So here's a great example where you got three modes of action that work very close to each other on the nervous system, but they do, just like with pyrethroids and doxycarb, they do the exact opposite, but they wind up with the same result, which is a dead insect. Okay, now we have the GABA chloride blockers, and this is an interesting one, and it has old chemistry. This is essentially, it's the ethiprol and fipronil, pretty much the only two products, and also, I guess, any cyclodienes that are left in the market. And this is a receptor that's much closer to the muscle fiber. And this also, it impacts the neurotransmitter receptor, and the phenylpyrazoles, what they do is they affect the chloride channel blocker, which essentially kills the insect. Okay, and so now let's move into the muscle. So what we've done is we've gone from the central nervous system, from the sodium channels down into the motor nerve, and now we're in the muscle. Now, in the muscle, there are receptors called ranitidine receptors. And actually, ranitidine receptors occur in lots of places, but there's a lot of them in the muscle, and they're absolutely critical for muscle contraction. What do the diamides do? You have chlorantraniliprole, cyanotraniliprole, flubendiamide, tetraniliprole. Okay, so you got a number of diamides on the market today, more coming, but they all do the same thing, and that is they release stored calcium ions. They open up the ranitidine receptor, and unchecked, all the calcium flows into the muscle, and it results again in paralysis. It's amazing how many of these modes of action, how many of these products essentially paralyze the insect, and sometimes they starve to death, which is essentially the cause of death. But this one happens to be the calcium. Okay, and then we move to another nerve target, and this is what we're calling the glutamate chloride modulators. This is a mouthful, but what's interesting is there's quite a few of them, and they're spread out over the nervous system, and they're also right there on the interface with the muscle. And these are also chloride channel inhibitors. And here, this mainly right now is mainly the avermectins, abamectin and emamectin. Okay, and then this is the most interesting one. It falls into the category of muscles and nerves, but this is on the outside of the insect. And this is what we call a chordotonal organ, which essentially it's an organ that's in the antenna. It's in the joints of the insect, and insects have different types of receptors there where they're able to monitor environmental stimulus. And what do they do with that stimulus? They then send it through the nervous system, and they send it to the muscles. And they these stretch receptors essentially tell the muscles hang on to the plant, run, flight, or fight. And so this one particular insect, pymetrozine, and also there's a new one on the market, phytopyropen, which is, again, both of them the same mode of action. They affect the receptor. They affect how it functions. And essentially what happens is that messages then are not sent to the muscles. The insect falls off the plant. It can't hold on to the plant. It can't locomote. It can't move. So a very interesting mode of action, but it's also a bit slow too. Okay, so we just completed now the nerve and muscle. So now we're going to move into another fairly large category, but I can really summarize this actually fairly quickly. And this is the category that really that contains the growth regulators. And when I say growth regulators, we're talking about lepidopteran larvae that have to molt. We're talking about other types of piercing, sucking insects, homopterans, hemipterans that they don't necessarily molt, but they do go from to different instars, but all of them have to go from some type of an immature stage to an adult stage. Essentially, all of the insecticides in this category have some type of effect on a dixone and on a juvenile hormone. A dixone, essentially, it releases, is a product that's released and induces molting. So when we look at the lepidopteran larvae, we have some larvae, many larvae that go through 2, 3, maybe 4 instars. There's some that go through 7 instars. Then they pupate, and then they go through metamorphosis to an adult. If you disrupt the ecdysone, you disrupt the molting, what happens is then you can persistently create an ecdysone, which means the insect doesn't molt, or it tries to partially molt, or it tries to partially pupate. It's not successful in pupating. It can't remove the exoskeleton that it has around its body, which contains chitin, and it dies. And I've got a picture that I'll show you in a minute. Juvenile hormone, very simply, prevents molting to a more mature stage. So if you look at the level of juvenile hormone here, there's a high level of juvenile hormone when the insect is a juvenile, when it's immature. But then at a specific time, the titer or the amount in the blood drops off. That's then an indication to the insect, and there's chemistry that goes on that says, okay, now it's time to pupate, or it's time to move to an adult stage. Well, if you can have a juvenile hormone mimic that you can spray, what happens is that the insect never makes it to the adult stage. It stays as an immature stage and then typically does not survive. This is a result of what insect growth regulators do. So you can see all the different types of various methods or various observations that you can make where insects are unable to molt. You have pupae where the adult's not able to emerge. You've got larvae here that get partially out of their exoskeleton, but then they get restricted and they wind up dying. Lower right-hand side, you see an untreated larvae, and then you can see all these other larvae which are being affected. So juvenile hormones have a horrendous impact on the insect as it's trying to molt. But it can be a bit slow because you have to wait for it to go through a particular instar, or you have to wait until it reaches the adult stage, but still a very effective group of products. And there's a lot of them. As you can see here, you got all different modes of action. Again, they act at different sites on the insect, but you got chromosome, buprofezin, lufenuron, spirotetramat. So you've got quite a number of different types of products that represent a lot of different modes of action, but they all have some impact on molding, disrupting molting, inhibiting chitin production. Okay, so they are your growth regulators. Let's move to respiration. There's only one slide here, and this happens to be 2 modes of action that impact mitochondria. Now, mitochondria are absolutely critical because they produce energy, not just in insects, but in humans and invertebrates. Mitochondria are really, they're the energy producers within our bodies. They actually transfer oxygen into energy. And so it's a great site for control, but one that you have to be a bit cautious because this is a critical life-sustaining process in humans as well. But you see diphenthioron, and then there's a number of other products, phenazequin and pyridine and tolfenpyride, but they all do the same thing. They disrupt the mitochondria and their production of ATP or the production of energy. So then let's move to midgut, and that's really the last category that I want to discuss. And this really covers all the BTs. And this is essentially the same as BTs that really are in your GMOs. Essentially, it's pretty much kind of the same. Also, baculoviruses, so it's two different group numbers, 11 and 31. But what happens specifically with BT is that it has spores, and that's what you're spraying out there. You're spraying the spore-forming bacteria, and it produces a toxin in the gut of the insect that's very specific to insects, does not have impact on humans or any type of a mammal. And then the toxin crystal gets dissolved, but it gets dissolved by an enzyme that the insect produces. So the insect really is responsible for creating a toxic form of the BT crystal. And then what it does, it really is very efficient at disintegrating the cells in the stomach, and essentially it dissolves the insect. And so a lot of BTs in the market, and they are very effective and against the insect, but very safe to non-targets. So I have a concluding slide here, because now after going through all these classes, someone may say, okay, well, what does all this mean? Does it mean that we should be rotating specific mode of action products that are in a nerve and muscle class with each other? And the answer is no, not specifically. That's not the recommendation. Should we be rotating modes of action that are in the nerve and muscle class with those that are in the growth or the respiration? No, not necessarily. Now, the bottom line is you want to rotate all the modes of actions. Doesn't matter which ones you rotate with, within a category and across a category, using the 30-day window rotation strategy, and ideally not to treat successive generations. And I'm going to leave you with this slide. Again, once again, for insecticides, we want to rotate, do not treat successive generations. And finally, the last word here is managing resistance is a hell of a lot more difficult than preventing resistance, okay? And that's why we want to concentrate where there's susceptibility. We want to work on maintaining that susceptibility. Okay, that is it for me.
Okay, thank you very much, Dr. Andaloro. I can just imagine how tired you are just discussing the number of modes of action. Used to be just 28, now it's more than 30, so that's a very
All right, yeah, it gets longer every time.
Yes, thank you very much. So in the interest of time, it looks like we only have enough remaining time for one question. And we have one. Oh, I see here from Mr. Eric John Cruz. He says here in the slide, MOA guidance document, what is the rationale behind the change in color of the group number and the background, in closing parentheses here, from white text in black background to black text in gray background?
The bottom line is look for the number. It'll be on the label. It'll be in communications. Don't worry about if the background's gray, if the background's black, or the background's white. You're going to see a number, and that is what you focus on.
Okay, so thank you very much. I believe I would like to again repeat that questions we cannot answer now, we will be answering them to you via email. So please don't hesitate in giving us the questions. We will respond to them via email. So Dr. Jan Andaloro will be responding to them. So,
and Audie, we need to make sure that these presentations are available to anyone who wants them.
Yes.
Whether in both PDF form as well as in PowerPoint form, so that people can take slides out if they want to use it for communication to their customers.
Thank you very much, Dr. Andaloro. We'll do that. it was part of the agreement within the resistance management group. Thank you. So I will be giving the floor to Jerwin already.
Thank you, Sir Audie and Dr. Jan, for that very informative discussion about further understanding on the MOA. I would like to call on the Executive Director of CropLife Philippines, Director Ed De Luna, to share with us the plans and what are we going to do as we move forward. Director?
Thank you very much, Gerwin. Well, at the outset, I would like to express my sincerest thanks and appreciation to our two speakers, Florence and Dr. Jan, for sharing their knowledge and expertise on the respective topics and taking time with us to share valuable information to our stakeholders. Let me also take this opportunity in behalf of CropLife Philippines and its member companies, and maybe in behalf of the whole pesticide industry, expressing our gratitude to the leadership of the Fertilizer and Pesticide Authority under Director Willie Roldan for decisively putting into force this policy of mandating companies to include mode of action labels in their products, and that is a quite a long work in the making. Thank you also, Director, for engaging us industry for giving us the opportunity to express our position in crafting this very important policy, and for that we are very grateful. And of course, to the participants who attended this morning, I believe we have lots from the industry, we have lots from our partners in the government, we have from the National Crop Protection Center, UPLB, and I think I saw some a couple of dealers, pesticide dealers who also participated in this webinar. Thank you for taking time. We shall be sending to you in the most convenient way your respective certificates of participation signed by me as Executive Director of CropLife Philippines and Ms. Florence Vasquez, the chair of the Resistance Action Committee of CropLife Philippines. And likewise to Jan, accept our sincerest thanks for sharing your expertise in today's webinar. The question is, what shall we do after this? I think CropLife President Bing Tiborcio in her opening statement made it explicit that the most important thing is, where do we proceed from here? I have listed here several actions forward which we can do together. First and foremost is, of course, we have to strengthen this industry coordination between the industry and our colleagues from the government, because promoting insecticide resistance management and mode of action is not a simple task. It would require the close coordination of all stakeholders within and outside of the government, or within and outside of the industry. so that we can reach, we will be able to reach our ultimate clientele or partner, the farmers. Of course, for the industry, we can, well, this is given because we must now start. I think several member companies have already started on this prior to the release of the current guidelines. But of course, now we're expected to include mode of action on your respective product levels. There was a question raised or a suggestion raised by Dr. Magsino during the open forum that we should reach out. Of course, the assistance of and cooperation of industry technicians and government technicians are necessary. But you know, in actual situation, the first person that a farmer approach when asking for a crop protection product are the dealers. So we must endeavor, I think, to educate and mobilize our dealers to reach out to the farmers to help us cascade this information. In all due respect to our resource speakers or our expert today, their presentation are quite comprehensive. It discussed a lot of things, but I think one of the way forward is how to come up with a user-friendly or farmer-friendly information materials on resistance management of mode of action and mode of action labeling. That would be necessary because owing to the level of educational background of our farmers, we have somehow to come up with materials that can be easily understood. It could be in a printed form, audiovisual. Actually, we have several initiatives already, but I think we should fine-tune it more so that it will be more user-friendly, so that we can reach as many farmers as possible. And most important, I think, is, well, this is just a request from to our colleagues in the government that could it be possible that mode of action, resistance management, and mode of action labeling be mainstreamed or included in the extension curriculum on pest management of our national and local government units. That is an ask from the industry, which I think we can work on together. Lastly, before I forget, I would like to express my sincerest thanks to the board of directors of CropLife member companies. I think some of them are in attendance. Thank you very much for your continued support to the undertakings of CropLife, and for also lending some of your people, your key staff, in pursuing the initiatives of CropLife. I know they have several jobs in your respective companies, but they still managed to come with us and work together in pursuing our common initiative. And to the members of the team, of course, for the past month, we worked so hard in preparing this webinar. Although there are some minor glitches, of course, related to connectivity, but still, I think we have managed so far. This is a good activity. Thank you, Flo. Thank you, Audi. Thank you, Jerwin, Bowie, Beth, Chat, Thank you very much, and we hope to see you in the next of the series of webinar on resistance management, tackling on another two important concerns, herbicides and fungicides. To our guest, I think we have friends colleagues from CropLife Asia, Regional IRAC. I saw Srinivas there. I don't know if Susan Knight, maybe she's there. And our colleague from Indonesia or Malaysia. Thank you for participating. Maraming salamat po at magandang umaga sa inyo lahat.
Thank you very much, Director Ed De Luna, for that message. And I agree. And as he said pala, this is not going to be the first time and the last time that you're going to see CropLife webinar session, because as mentioned from the first slide of President Veronica Tiburcio earlier, we have an upcoming projects like the resistance management, talking about herbicide resistance management and also fungicide resistance management. So the dates for these sessions will be arranged in the future. So we will let you know. We will keep you posted. Abangan nyo yan. And for sure, the next sessions will be more exciting and more lively. And also we will spend more time on answering the questions and inquiries of our dear participants. Right now, we have 141 participants in attendance. We peaked earlier about 150, I guess. So congratulations to all, and thank you for sharing your time with us. This is just a very, very short preparation for us here in CropLife, especially the stewardship and the RAC team. Guys, congratulations to all the panelists and to all our speakers, invited guests. Thank you for attending. And also, final and last announcement before you leave. Once you leave this webinar, you will be prompted by a survey questionnaire. And we would like to request you to kindly answer the questions in the questionnaire once you logged out. There are just about 3 to 4 questions. And we will appreciate it if you do not skip it, all right? And for more useful information on the topic today, follow us on our social media account. For Facebook, we have at CropLife Philippines. For our YouTube channel, we have CropLife Philippines. And for our website, www.croplife.org.ph. And guys, thank you again for that very, very nice 2 hours, I guess. And see you all next time. Stay safe, healthy, and COVID-free. Bye-bye. God bless.